Hello, and this time we're interpreting histograms, although that's not the best title. It's more sort of mucking about with them and seeing the kind of questions they can throw at you in a GCSE exam where it's not just a simple case of draw a histogram and move on with life, but what you can work out from it and what they can try and make you do. So if you haven't already seen the other video I've done about histograms, what they are and why we do them, then go and check that one out first. But essentially we're not plotting frequency, there's not a bar chart because we have unequal widths of our groups. If these groups are not all equal, you must not draw a bar chart, and we don't plot frequency, we plot frequency density. And frequency density, or FD, is worked out as the frequency divided by the class width, which is how much space is in between these two numbers, the width of those groups. Now this is a classic GCSE question. They've given us a half-complete table and a half-complete histogram, and we're told nothing about the scale. We just got to figure out how to complete the histogram. So let's just move that up there so we've got a bit more space. Now what you'll find is that one of these bars is given in the table and in the graph, and it's this one here, 16 to 20, and that's giving us an 8. And this is going to give us the scale of our diagram. So we need to work out what the frequency density is for all of these numbers. So that's the frequency divided by the class width. 16 to 20 is 4, so 8 over 4 is 2. Which means that this line here is 2. I think it's supposed to be on the grey line there. So if that's 2, yes, that's what we worked out, so that must be at scale of 2, then 2 little squares is 1. Okay, so 2, 3, 4, 5. So a big square is 5. 10, 15, 21 we've got there. Okay. As the frequency, not that we really need to know that, but sometimes they want you to fill in the table as well. So for this one, if we're going back to the table, we know that the frequency density is 21, so it's here, 21 equals the unknown frequency over the class width. Well, 14 to 16 is 2, and if we rearrange that times both sides by 2, then that gives us 42 as our frequency. But we're actually asked to fill in the histogram, so let's work out the frequency density for the other numbers. 6 divided by 2 is 3, 21 divided by 1 is 21, 23 divided by 1 is 23, and those two are already drawn. So between 10 and 12, so that's nice, between here and here, we're going to draw 3, which is going to be there, or thereabouts. The next bar is 12 to 13, so it's only going as far as halfway, and it goes up to 21. 5, 10, 15, 20. Oh, sorry, what am I doing? Oh, no, it is. I saw that and thought it was a 4, because my poor handwriting. It is 21 because we divided it by 1. So we're going up to the same height as this one, so all the way up to 21 and back down. And then this one's 23, so it gets an extra little bit higher on top of that one. And there's our histogram pleasantly completed. I have got a couple of other examples for you. Here's a histogram showing information about the weight of pigs. And this time they've given us the whole diagram, so that's delightful, but they haven't labelled their axis. How rude. So hopefully they've given us some more information, and they have. 30 pigs weigh between 50 and 65. So between 50 and 65, that's one group, thank goodness, and we're saying that that's 30. That's the frequency. So frequency density, which we don't know, is 30 divided by the class width, and the class width here is 15, from 50 up to 65. So the frequency, 30 pigs, divided by 15, that's going to give us a value of 2. So that's 2. That's 4, that's 6, and that's 8. So we now can pick out the numbers. Now there's a few things you can do, and I'm going to go off question for a bit because I want to show you a variety of things you can do. But this is one of the most classics. If we just do part A first, work out an estimate for the number of pigs which weigh more than 80 kilos. Okay. Now, unfortunately, it's not just a straight case of looking at which groups are over 80 and it just being these two and nothing else. It actually cuts this one in half. That's the problem. So it's everyone in here, and if we had the table, we just read it out, and here it's cutting this group exactly in half. So that's nice. If we had the table of data, we could just say how many is that and just half it, but we don't, so we're going to have to work out the frequencies from the frequency density. This is a density of 4. It is 80 to 85 wide. Okay, if frequency density is frequency divided by class width, then frequency, whoops, handwriting going all over the place, the frequency is the frequency density times the class width. Okay, in which case the frequency for this bit is density of 4 times a class width of 5, and 4 times 5 is 20 frequency. And then for this group, again, if we had the table, we'd just read it off because it's the whole of this group. This goes up 1 high and is, what's that, 15 wide. So 1 times 15 is a frequency of 15, and we want both of these sections, so we add them together, and the answer is 35. Explain why your answer to part A is only an estimate. Well, we don't know that these people are evenly spaced with half of them above 80 and half of them below. That's our assumption that we're making. We're assuming all of the values are evenly distributed over the class. Now, there's a couple of other things I want to say just before we leave this one, which is they might ask you to find the mean or the median. If they've asked you to find the mean without telling you the table, they're a bit mean. Mean. Because about the mean, never mind, because you're going to have to work out the frequency for each of these blocks. And then when you have the frequencies, you can do the normal table where you have the frequency, the values, which will be the midpoints between each group. So there will be that one, yes. So the midpoints of each group times each of the frequencies, add them all up and divide by the total frequency. Working out the average from group data is another video that you can look up if you need to. And what about the median? Well, if we want the median, then we want the middle person. And again, that means we have to find out how many people there are in total if they don't tell us. They sometimes tell us the total amount, but they haven't. So again, we're going to have to work out all of them. So we may as well just crack on and do it. So 15 times 2, that's 30 people. That's 5 times 6, which is 30 people. 5 times 8, which is 40 people, not people, pigs, sorry. 10 times 4 is 40, and we already worked this one out, 1 times 15 is 15. So we can add all this up, 40 and 40 is 80, 110, 140, 155. So there's 155 people in total. We want to find the median or the middle person. So what's that going to be in here? So 155, we add 1 and we half it to find who is the median person, the 78th person. So where is the 78th person? Okay, well, we're still not there yet. Here we said, I don't know why I erased all my numbers in my, there we go, in here. And what did we say? We want the 78th person is the median. So here's 30. Here's another 30. That makes 60. Okay, and we want 78. So we've got 60 so far to here. And we now need to, what have we got left? 18 people through 40. So what fraction of 40 is 18? It's 9/20. So 9/20 of the way between 70 and 75. Okay, so it's almost halfway, isn't it? But it's not quite. So if it was halfway, it would be kinder. It would be 72.5. That would be where that median person is. So again, we're assuming that all these 40 people are evenly spaced between 70 and 75. But as that's not the case, then we need to times that by 5, because that's the width of that group. So we get the same fraction through the group, and then we add that on to 70, because that's where the group starts, and it's 72.25. So we weren't too far off. But that is an estimate of the median by finding whereabouts is the halfway. Yeah, how many people are there in total? So where's the halfway person? And if he's in the middle of a group, then you've got to sort of go proportionately through the group. You don't see that very much in GCSE. That's more of an A-level question. So don't worry if that's a bit much, then focus on the other questions. Okay, and the last question I've got as an example, work out an estimate for the proportion of plants over 25 centimeters tall. And again, they haven't told us the frequency density scale, but that's okay because we don't need that. The proportion of plants over 75 centimeters tall, well, the number of plants or the frequency in a histogram is related to the area of the bars, not the heights. So all we need to do is we need to work out how much area there is, regardless of what the scale is. So we can either make up a scale here, or just literally we can count the numbers. Count the little squares. 1, 2, 3, 4, 5. So that's 10 little squares by 10, 11, 12. 10 times 12, 120 little squares. This is 5 times 10, 20, 32. Okay, so 32 times 5. No shame in getting the calculator out for calculations if you need to. 10, 20, 30, 40, 1, 2, 3, 4. 44 times 5. Should be able to do that in my head, but never mind. It's quite late. 220. Here we've got the same block as before. 10 wide, 12 tall, 120. And here we've got one that is 20 across and 3 up. So that's 60. So that's how much area we've got in little squares. And this is proportionate to the amount of plants that we have. So if we want to know what fraction, what proportion are above a certain height, then we just have to work out what that area is out of the total. So I'm adding up the total now, and plus, oops, and the 60. So the total area is 680, and we want the proportion over 25 centimeters tall, which is here. And that's nice because it's halfway in the block, so I don't need to do any crazy interpolation like I did on the last question. Halfway in the block is half of 120, which is 60 for that bit, but also the 60 here, so it's 120 in total over 680, and let's simplify that down on the calculator. And so that's 3/17 of the plants are greater than 75 centimeters tall. And if it asks you why is this an estimate, of course the estimate word here doesn't mean have a guess. It doesn't mean like, well, it's about. No, you follow a very strict method. It's an estimate because we're having to assume that all of the plants, however many there are in this group, are evenly spaced. So there's one there, one there. Yes, they're all got different heights. If all of them had the exact same height, well, then our calculation would be different, wouldn't it? If in this group, you know, all of them weighed between 25 and 30, well, then the answer would be 180, because all 120 are here and none are there. And likewise, if they're all below 25, then the answer would be 60, because there'd be none in here. And we don't know. We don't know how many, what the values are for each one. What we have to assume is they're evenly spread across the group, and therefore, if we want to know for halfway through the group, we assume that we've got half the group and any groups above. I'll go now because this video is getting quite long and you don't want to hear me rambling on any longer. If you have any questions, then you can pop them in the comments, but otherwise, cheerio.